to all those who devoted their lives to aviation. The Wings of Russia studio presents. Wings of Russia documentary. An air show takes place in Zhukovsky once in 2 years. This event attracts thousands of people. Bombers, airliners, helicopters are both on the ground and in the sky. But only fighters become stars of the show. Capabilities of a 21st century fighter are astonishing. The multi-ton machines tumble in the sky as if denying classical laws of aerodynamics. They leave no doubt the enemy in an air battle will be defeated. Fighters, a struggle for superiority. An enormous air parade took place at the Domodedovo airport in 1967. It showed what jet fighters have achieved from the moment of their appearance. At the same time, the future aircraft were demonstrated at the parade with absolutely new fascinating capabilities. The Domodedovo air event somewhat drew a line between the old and the new fighter generations. Later there appeared a term, the fighter generation, although such division in itself was rather tentative. An aircraft was attributed to this or that generation if it had a set of certain characteristic features. For example, fighters of the first generation such as MiG-15 and MiG-17 had subsonic speed, cannons and no radar. Aircraft of the second generation, like MiG-21, were supersonic, equipped with mostly missiles and so far very primitive radars. Evolution follows a classical way. Engine power becomes greater, means of early warning and destruction develop, aerodynamics improves. But the fighter's history is also a history of wars. In the Domodedovo air show, along with the aircraft of the first two generations, prototypes of the third generation fighters were shown. World events happening at that time produced a great impact on their future. Rethinking of the fighter concept was caused by the war in Vietnam. Since it was part of the Big Cold War, Soviet specialists helped North Vietnam to stand against American aggression. Besides, Vietnamese pilots flew on Soviet fighters. It was in the confrontation with the American aircraft that the priceless combat experience was gained. The main component of this experience was in the air confrontation of the Soviet MiG-21 and the American Phantom, the main fighters of that war. Long before the combat actions, the fighter cannons were abandoned. The words of the then U.S. Defense Secretary Robert McNamara were remarkable. Cannons on a fighter in a modern warfare are as archaic as fighting with a bow and arrow. Fighters were thought to be exchanging missile attacks at a distance, conducting no close fights. Such understanding was wrong. Most of the air battles turned into close fights. Cannons were back on fighters. But not only cannons predefined success. Maneuverability was the key point. Heavy Phantoms with all their missile armament were helpless in countering light and quick MiG-21. Statistics showed that out of every fight shot down aircraft, 4 were destroyed in a close fight. Vietnam War experience changed a lot the views of what a third-generation fighter should be. In the Soviet Union, MiG-23 became representative of the new generation. Its design was started long before the described events. Accent was made on a more powerful missile armament. A new radar was also required that could identify targets not only in the sky but against the ground. Higher speed and longer range requirements were still on the agenda. All this inevitably led to the aircraft weight increase and, as a result, to longer run at takeoff and landing. This could not satisfy Air Force. Long runways were easy targets. Something new was needed to maintain both high speed and adequate takeoff and landing characteristics. Rushing for speed, designers continuously increased the wing sweep. On MiG-15, it was 35 degrees. On MiG-17, 45 degrees. On MiG-19, 55 degrees. MiG-21, 60 degrees. But with a more swept wing, its efficiency at takeoff and landing was becoming lesser. Designers offered 2 solutions. The first was to use additional lift jet engines. The second was to use the variable swept wing. Both variants had competent supporters and critics. 2 prototypes were built for comparative tests. One with the lift jet engines and the other with a new wing. Both aircraft were called MiG-23. The first was tested by Pyotr Ostapenko, while the second by Alexander Fedotov. Tests showed that the variable swept wing aircraft had more advantages. Both machines were shown at the 1967 Domodedovo Air Parade. While for the lift jet engines MiG, the show was the end of its career, for the swept wing aircraft it was just the beginning. Initially, MiG-23 was not meant for a close combat. Its maneuverability was therefore limited. However, by the start of its service, the concept totally changed. After the Vietnam War, the Army wanted to have a maneuverable fighter. The aircraft was thought to be tested in the relevant flight modes relating to heavy load on the aircraft layout. While maneuvering, the aircraft began to crack. It was then upgraded, aerodynamics was improved, a more powerful engine was installed, and the layout was reinforced. The new variant was named MiG-23M. It was already a fully featured fighter. Now its swept wing worked well at various regimes. It was taking off and landing with a straight wing. The maximum sweep allowed it to reach up to 2,500 kilometers per hour, while the mid-sweep allowed to conduct a maneuverable airfight. A cannon on a fighter was no more disputed. No new missiles were needed either, since there appeared new methods of conducting an airfight. Close-range R-60 missiles were now in the arsenal of the aircraft. Even a very maneuverable target could be hit by such a missile. But the main weapon specially made for MiG-23 was the mid-range R-23 missile. It could have both infrared and radar homing heads. Different target lock-on principles significantly increased the fighter's chances for success. In 1973, MiG-23 joined the Air Force. New aircraft in those years were joining air units continuously and in large quantities. Aircraft were mastered by both experienced and young pilots fresh from air schools. Such schools in the Soviet Union were in abundance. There was no lack of fuel, so each pilot could perform several flights per week. The military pilot profession was very prestigious. MiG-23 was supposed to completely substitute the previous generation fighter MiG-21. But while MiG-23 was being worked out, a new modification of MiG-21 was made. It was called MiG-21 bis. The fighter was doomed to be back on stage. Its maneuverability was initially fine. Other flight characteristics required improvement to increase the aircraft combat capabilities. The engine of MiG-21 bis, besides the usual afterburning regime, had also an extreme afterburning regime. For a short period of time, it could build up a twice bigger thrust. For example, such important characteristics as the rate of climb was growing up to 235 meters per second, twice as much as compared with the MiG-21 previous variant. MiG-21 bis resulted from a 15-year search for an optimum combination of different qualities and became the most advanced fighter of its huge family. This modification showed that definition of a family was rather tentative. And while the first variants of MiG-21 by all their characteristics referred to fighters of the second generation, the bis variant was already close to the third generation. MiG-21 bis was in no way inferior to MiG-23 in terms of maneuverability. So it was too early to think of any complete substitution of MiG-21 for a new aircraft. Both fighters perfectly complemented each other. Interesting enough, but it was a competition between two aircraft of one and the same design bureau. And while MiG-21 gave away its maximum, the MiG-23 potential was not yet spent. Further increase of its maneuverability was seen in the weight reduction. That's how MiG-23ML appeared. It was light, equipped with a more powerful engine capable of sustaining critical for the variable swept-wing aircraft 8.5 G load. Pilots experienced the same G loads. Partially, the load was reduced by a special pressurized suit, but even then the G load was close to the utmost level of human endurance. Therefore, pilots needed to have a relevant physical form. Only the best were selected for the team aerobatic demo flights. Although in those years such flights were not meant for any wide public demonstration, aerobatic teams, 3G and the Russian Knights, will become known all over the world later on. Probably the most important feature of the MiG-23ML fighter was its radar capable of seeing targets against the ground. The requirement stated at the initial stage of the MiG-23 development was fulfilled. The aircraft's improvement continued. MiG-23MLD became the top version of the family. MiG-23 evolution is a typical example how combat qualities were influenced by numerous other factors. And if before many of them could be victimized for the sake of speed, now it was already a deliberate and well-thought development in every direction. Aircraft were becoming more complicated, expensive, but more efficient. Any technical novelty was immediately put into action. All was aimed at making everything at least a little bit better than with the enemy. Such was the Soviet fighter of the third generation. In general, the third generation of the world aircraft development as no other remained as a generation of research, trial and error. Developing its Mirage F1, the French went the traditional way. The aircraft at least looked quite ordinary for its time. while the Swedes used an interesting layout for their vegan fighter. The engine was equipped with the thrust reverse, which was unusual for this class of aircraft. This option allows to shorten the landing run without the brake parachute. The Swedes happily demonstrated the thrust reverse at air shows. Americans did not have any third-generation fighter at all. Rather, they started its development even before MiG-23. It was called F-111 and thought to be multifunctional. But because of that, the aircraft became large and heavy, and with a later Vietnam War experience, it was not at all a fighter. Americans did not insist it to be a fighter and quickly turned the aircraft into a tactical bomber. However, they faced a gap in the fighter generations. Partially, they covered it with the Phantom last modifications and immediately opened the tender for the fourth-generation fighter. But we'll talk about it later. In the meantime, let's speak about interceptors, for which most important was not maneuverability but speed and flight altitude. Throughout many years, air defense of the USSR badly needed an interceptor. The reason was that the NATO countries conducted active air reconnaissance, not only along the Soviet borders, but often entering the airspace of this country. By the end of the 50s, the Sukhoi Design Bureau developed Su-9 and Su-11 interceptors, but their armament and onboard equipment could not stand against air intruders. Next step in the air borders protection was Su-15 interceptor. Its layout was principally different from its predecessors. Prior single-engine Sukhoi aircraft had a nose air intake, while there was no place to install a powerful radar so important for an interceptor. The new twin-engine Su-15 had air intakes on both sides of the fuselage, clearing the nose to install the radar. Besides, two engines provided for more reliability and higher flight characteristics. However, it was hard to reach such characteristics on the first versions of the aircraft. The Su-15 landing speed was so high that the aircraft could overrun the runway. The problem was resolved with the interceptor's next modification by installing a larger spaced wing. Such wing is called the cranked delta wing. Su-15 could intercept targets in a wide range of altitude and speed. It worked in cooperation with the land-based guidance stations. The sequence of actions was the following. First, the intruder was detected by the large land-based radars. Then interceptors would take off. They were homed from the ground, and at a certain distance, their onboard radars would get into work. The pilot would locate the target and perform friend or foe identification. Such system appeared at a stage when interception became possible in the event the pilot could not visualize the target. The system was global, and all Soviet airplanes, both military and civil, had the corresponding equipment. After catching, the target had to reply, "Friend, do not attack." If the target was silent, the decision was to attack. Basically, Su-15 was meant for a big war. Besides high-altitude reconnaissance aircraft, potential targets were supposed to be cruise missiles of the first generation and strategic bombers. But in the Cold War reality, all kinds of targets had to be intercepted. They were mostly minor private planes piloted by amateurs entering the Soviet airspace by mistake. But Su-15 designation was different, and capabilities of its radar not always allowed to detect such minor targets. As to interception of larger airplanes, at least 2 accidents involving Su-15 were widely known. Both cases involved passenger airliners crossing the air border of the USSR. In both cases, interceptors terminated their flights. First entering Air Force units in the end of the 60s, Su-15 served for 30 years. It was the most mass Soviet interceptor, which total production amounted to 1,400 machines. 28 air wings all over the country were equipped with this aircraft. Concrete cover positions to save expensive air equipment were built at airdromes. They could protect aircraft not only from bad weather but from nuclear attacks as well. Life in the air defense units was active, since they were providing for the air security of the country. Any first flight of a young pilot was marked as a special event. The Cold War confrontation led to appearance of the potential enemy's new combat aircraft. Some of them already could fly with Mach 3 speed. An interceptor with the corresponding flight characteristics was required. Thus, the story of MiG-25 started in the beginning of the 60s. A while ago, aircraft passed the sound barrier. Now, when the Mach 3 speed was reached, there appeared a new heat barrier. Calculations showed that some elements of the aircraft layout would heat up to 300 degrees Celsius. This caused a revolution in technologies and materials. Instead of traditional aluminum alloys, steel and titanium was applied. Welding substituted riveting. High temperatures required special protection for the pilot, equipment, and armament. The aircraft was made in 2 variants: MiG-25R reconnaissance aircraft and MiG-25P interceptor. In autumn 1964, test pilot Pyotr Ostapenko made the first flight on the new interceptor. The MiG-25 outlook was very unusual. Large air intakes, huge wheels, 2 fins, enormous engine nozzles. The takeoff weight was 36 tons. Never before the Soviet aviation produced anything of the kind. It was a unique aircraft governing super speeds and super altitudes. Fully armed, MiG-25 could climb up to 20 kilometers. Its cruise speed was 2,500 kilometers per hour with a maximum of 3,000. The aircraft had adequate systems. Its unique radar could detect a target at a range of 100 kilometers. Its R-40 missiles could destroy an enemy at a distance of 30 kilometers. The word unique best of all describes the MiG-25 capabilities. With its entry into service, the country's air defense stepped to a new, more higher level. Those willing to nose into this country seriously diminished. It was highly prestigious to fly such an aircraft. Mach 3 speed, an altitude when instead of a blue sky there is a black outer space above. Not everyone had an ability to feel all this. Admittance to such flights was not easy since they had certain specifics. While reaching a certain speed and altitude was not difficult, return actions required more concentration from the pilot. It had to reduce the speed and flight altitude of a strongly heated aircraft in a strictly determined mode. Other MiG-25 operations were not much complicated than with other fighters. It did not create problems for the maintenance personnel. Despite its outstanding flight characteristics, the aircraft was as easy in servicing as other machines. Air wings equipped with MiG-25 were located at the most dangerous locations, right near the border. At special parking lots, fully fueled and armed, MiG-25 performed day and night duty. At alert, on-duty pilots would take their places in the cockpits and start off to intercept. As a rule, arms were not used. Usually, it was enough to fly along the border at high speed, showing missiles under the wing. You see MiG-25 and Su-15 interceptors showing their power at the major air defense maneuvers Soyuz-74.
Азимут 220, удаление 250, навести 107.
Maneuvers normally were conducted regularly and at large scale. Interceptors would fly in groups, pleasing high command and performing demonstrational missile launches against unmanned aircraft targets. There seemed to be nothing more stronger than this defense shield. But on September 6, 1976, there occurred an event significantly undermining such confidence. Senior Lieutenant Viktor Belenko hijacked the super-secret MiG-25 with the board number 31 to Japan. Together with the aircraft, codes of the friend or foe identification system got into the hands of the enemy. Both the pilot and the aircraft were demanded to be returned back. However, USA granted Viktor Belenko political asylum, and the aircraft, before returning, was diligently examined by the Japanese and Americans. Their assessment was rather high. Foreign experts outlined simplicity of the layout and equipment. They were surprised how well optimized the aircraft was for the sole purpose of catching up and destroying the target. Of course, Belenko damaged the country. The friend or foe identification system had to be immediately changed. But there is no great loss without something to gain. The system needed an upgrade, and the accident only expedited its refurbishment. Numerous other improvements were performed, bringing new qualities to MiG-25. Its next modification already had a radar capable of seeing targets against the ground. Even a small target flying at only 50 meters above the ground could be detected. The improved interceptor was called MiG-25 PD. The hijacking reduced the aircraft's confidentiality level, therefore lifting limitations for its export. MiG-25 was bought by a number of countries friendly to the Soviet Union. Thus, the potential enemy had now to deal with MiG-25 in various parts of the world. In the meantime, Mikoyan Design Bureau was actively developing its absolutely new aircraft with a lot more capabilities. It was MiG-31, which looked similar to the MiG-25 interceptor. Requirements for high speed and altitude characteristics remained the same. The novelty was that MiG-31 already represented a complex of long-range interception. The country's leadership was anxious about its northern border, where a possibility of the American cruise missiles attack was high. This border length is such that construction of many radar control units is doubtful. MiG-31 is supposed to close the defense gaps. If needed, this interceptor may long barrage at alarming directions. However, long stay on duty in the air is not all. A new armament system was developed together with the aircraft. Long-range R-33 missiles can destroy high-speed targets at a distance of 120 kilometers, both near the ground and at high altitudes. 4 such missiles are suspended under the fuselage, while the close-range R-60 missiles are placed on pylons. Interceptor has also a 6-barrel cannon. But most important is that for the first time in the world history, a combat aircraft was equipped with a principally new onboard radar with a phased array. Radars of prior generations scanned the airspace by mechanically turning the antenna. With a new radar, this is done electronically. The antenna reflector, in this case, may stay still. Mechanical scanning takes quite a long time, while electronic scanning gives the air situation immediately. The phased array can provide coordinates of several targets at a time. Detection range of the airborne enemy has increased. Now the target is visible from a distance of 200 kilometers. Besides the pilot, the crew includes an air navigator. He resolves navigation tasks and controls sophisticated armament. MiG-31 started its service in the 80s. An aircraft is not just for the roles at an air show, but for a real work. In order to perform such work immaculately, a lot of training is required. A day of flight in one of the air units, combat task receipt. The flight is first played on the ground. This procedure is called a walk-on flight. Engines are on. The aircraft taxis to the start. A steady working rhythm going on day and night. MiG-31 is an efficient combat system capable of warning autonomously, without the use of any ground homing. The interceptor can follow 10 targets and simultaneously attack 4 of them. A group of 4 aircraft can control a 900-kilometer wide airspace. The closed communication system provides for the radar information exchange within the group, where one of the interceptors can be a coordinator homing other fighters on targets. Radars of those aircraft are idle, and the attack becomes covered. In other words, the target sees that it has been screened by the radar from one side and gets a missile from the other side. At the May 9, 2008 Victory Parade, MiG-31 interceptors deservedly joined the line of other combat aircraft of the Russian Air Force. But let's get back into the 70s, when the United States introduced their fighters of the 4th generation. Confrontation between the USSR and NATO with the USA in the first place looked as a rush for advance. For each new armament of one side, the other responded with something more advanced, while the first would develop something more efficient. A kind of a swing, where one side after the other would get a bit higher. Developing the 4th generation and avoiding the 3rd, Americans gained the lead. They developed 2 aircraft, a light F-16 and a heavy F-15. The principally new concept was the use of a pair. Combat tasks were assumed to be different. One would be rational to perform by a lighter and more cheaper aircraft, while the other by the heavier and more powerful aircraft. By creating aircraft of the fourth generation, Americans introduced a new term, a fighter for the air superiority. Thus, the United States made its fighter. Now it was the Soviet Union's turn. 3 design bureaus introduced their projects. Competition was among the bureaus of Mikoyan, Sukhoi, and Yakovlev. Later on, Yakovlev's bureau stepped aside. That's when the decision was made to have 2 fighters, like the Americans had. The heavier was made by the Sukhoi bureau, while the lighter one by the Mikoyans. The first was the famous Su-27, the other no less notorious MiG-29. Both aircraft were performed upon a blended layout, with a wing and fuselage smoothly joining each other, making a single lifting surface. The aerodynamic quality of such a layout was much more higher than of the classical. By the way, in the USA, only F-16 was made upon a blended layout, while F-15 had a classical layout. The Sukhois were glad to know about that, since the use of the blended layout gave them a lead over the Americans. The first T-10 flight, as the Su-27 prototype was called, was made in May 1977. The aircraft was piloted by Vladimir Ilyushin. However, the first variant was not much of a success. Subsequently, the aircraft was redone so much that it became almost a new machine. As to MiG-29, it took off several months after Su-27 in October of the same 1977. The aircraft was piloted by Alexander Fedotov. Both fighters were commissioned in the beginning of the 80s. Their quantitative proportion in the Air Force was established. The heavy Su-27 made 1/3, and the light MiG-29 made 2/3 of the total. The first comments from the air wings showed that outstanding aircraft were developed. Their combat efficiency was way much higher than of any previous Soviet fighter. But it was important not to stay behind the Americans. The watch over the enemy's technical level was continuous, and the remote competition never stopped. Americans showed its F-15 capabilities in 1975, setting several world records. The aircraft, specially prepared for such records, had nothing extra, even no paint, only the name and a picture of an eagle. The Soviet aircraft started to beat the American records in 1986. It did not have anything extra as well, only red banners on the fin and the name P-42 on the nose. It was a special light version of the Su-27 fighter. The engines were forced at maximum, developing the thrust almost twice bigger than the aircraft's weight. But there appeared a problem. The brakes could not hold the aircraft at the start. Therefore, the aircraft was hooked to a heavy tow truck. When the pilot brought the engines to full power, the cables were unhooked, and after a short run, the aircraft rocketed into the sky. Enough to say that the aircraft could pass the sound barrier in a vertical climb. P-42 reached altitude of 12 kilometers within less than a minute. American records were beaten. In the end of the 80s, Su-27 and MiG-29 were shown abroad. The debut was triumphant. The intrigue was high because so far the Soviet Union never showed its military equipment at international exhibitions. The impression was great. It was clear that the fighters had an enormous potential. Indeed, both aircraft already had several modifications. The two-seat combat training Su-27UB and MiG-29UB, the ship-based Su-27K and MiG-29K, as well as the more improved basic variants Su-27M and MiG-29M. The new generation fighters just joined the service when a program for the new Perspective fighter was announced. And again, the same two companies, Sukhoi and Mikoyan, obtained the orders. On September 25, 1997, the Sukhoi aircraft was taken into the air by test pilot Igor Votintsov. The machine was encoded Su-47, the Golden Eagle. While the Mikoyan fighter took off in February 2000. It was piloted by Vladimir Gorbunov. The aircraft was identified as 1.44. The technical solutions and the fortune of the two aircraft had much in common. Both had an interesting aerodynamic layout. Both were made super maneuverable with the account of the stealth technology. Both aircraft were transferred from perspective into experimental category. The country entered difficult times, and it was decided to devote maximum efforts to modernization of the fourth-generation aircraft. Thus, gradually improving, Su-27 and MiG-29 became aircraft of the 4+ generation. The fighter aerodynamics came to a certain limit from the point of view of improvement. Any further technical development was linked to the progress in electronics. Modern avionics allows to optimize the task performance, in other words, to reach maximum result through minimum efforts. Quickly detect the target, lock on it, get steady hold of it, and destroy with one missile. Clearly, the pilot's work had changed a lot. Most of the flight parameters are now shown up not on traditional pointer instruments, but on an LCD screen. Capabilities of the modern avionics are such that even fighters of the previous generations obtain new qualities. The ideology of electronic congestion was used in the modern European fighters Typhoon, Gripen, Rafale. The American F-22 Raptor is made in the same way. Another characteristic feature of the 4th and 4+ generation aircraft is their super maneuverability. These fighters have thrust-to-weight ratio of over 1, which means that thrust exceeds the aircraft weight. In combination with the perfect aerodynamics, this radically changes flight principles. Aerobatic figures beyond all traditional limits appeared. One of the first among them was Cobra. This maneuver was first performed by test pilot Igor Volta. Cobra became world-renowned after it was demonstrated abroad by another test pilot, Viktor Pugachev. Moreover, Su-37 prototype took off in 1996. For this aircraft, Cobra was already an easy thing. Engines of this new aircraft had thrust vectoring nozzles. The same engines were installed on Su-30MK, the next Sukhoi aircraft. Vectored thrust allows this aircraft to do what ordinary fighters cannot do. There is a similar aircraft of the Mikoyan firm. It is MiG-29M with thrust vector. The concept of directional static instability was realized on the Su-27 and MiG-29 fighter families. It means that the aircraft is very sensitive to any minor control stick movement. On the one hand, this allows to make very sophisticated figures in the air. On the other hand, the aircraft stays on a very thin edge, keeping which the pilot is helped by automatic control. Aerobatic capabilities of the aircraft and avionics are not all that a modern fighter needs. A very important component of the combat complex is armament. The air-to-air missiles of the last generation totally comply with the fighters. For example, R-73 missile leaving its launch pad can immediately change path by 90 degrees, which is very important in a close fight. Missiles can now be homed by the pilot's glance, arranged by the helmet-integrated sighting and control system. The fighter's potential has grown so much that they can attack both airborne and ground targets with equal success. Combat aircraft arsenal now includes high-precision guided air-to-surface class weapons, missiles, and corrected air bombs. Missiles are based on fire-and-forget principle. The pilot does not have to keep the target in the aim all the time. If the self-homing missile head locks on the target, it will never let it go. The in-flight refueling system gives a fighter practically an unlimited flight range. MiG-29 and Su-27 have many different systems. Special attention should be devoted to the K-36 ejection seat, which saved a lot of pilots in almost hopeless situations. This seat was made by the Zvezda Design Bureau and is considered to be the world's best in its class. A story about fighters would be incomplete without mentioning the Russian aerobatic teams performing on MiG-29 and Su-27. The most renowned are the Strizhi and the Russian Knights, which need no presentation. And here is the Russian Falcons aerobatic team. Its performances include elements of a real air combat. The team represents the Lipetsk Air Combat Training Center. There, pilots from different air units obtain the highest qualification mastering the new aircraft. February 19, 2008. Airdrome of the Gromov Flight Research Institute. Test pilot Sergei Bogdan is getting ready to take the new Su-35 fighter into the sky. Su-35, an aircraft of the 4++ generation. Sometime before that, the Mikoyan firm introduced its own fighter of the same generation, MiG-35. The airframe of both machines represents development of the same fourth-generation fighters, MiG-29 and Su-27, while by their capabilities, they are closer to the aircraft of the fifth generation. To a certain extent, it's a glance into future. Russian designers are among those who are capable of creating a brand new fighter and whose authority in the aircraft construction is recognized worldwide. Modern fighters. The harmony of beauty and power, speed and maneuverability, a display of advanced technologies. It would be best to see capabilities of these aircraft only at air show. Any force is noble when it is not used.